Right, so we will continue with loading. So in front of you, this slide actually is divided into the left part and the right part. Right, the left part deals with distributed load. That's what we mentioned last week. And on the right side, we deal with point load, or another name that we talked about last week is concentrated load. Concentrated load is the same as point load. Right, so let's look at the right side. So we have a beam here, and there are two supports, no matter these two are columns or wall or whatever. So this could be a column or wall. Anyway, you got two supports. And the distance between the center line of each support, you can see that. That's the distance between the center line of each support. That's 4 meters. Right? So that length is called a span. That's the span of the beam, which is defined as the distance between the center line of two supports, and that's obviously equals to 4 meters. And at the center of the beam, or mid-span, span in Chinese is 跨度. Right, so at the middle of the span, you have a person sitting here, so you've got a live load. This live load, of course, is a concentrated load. So assuming that this guy is 50 kilogram. So first thing we are going to do is, for those who don't know what is kilogram, we need to change it to the unit of loading, right, or force. Right, so kilogram, if you want to change it to Newton, you multiply by 10. This 10, of course, it has a unit of meter per second square. For those who did physics before should know what that is. For those who didn't, doesn't matter. Just remember when you change kilogram to Newton, you multiply by 10. And in construction, instead of using Newton, we usually use kilonewton. So we change it to kilonewton. That means you divided it by 1,000. So that will give you kilonewton. So 50 kilogram is, if you change it to kilonewton, you multiply by 10 and then divide by 1,000. That will give you 0.5 kilonewton. Right, so at mid-span, you got 0.5, half a kilonewton. Right, so that's equals to half kilonewton. On the second diagram on the right, so the same beam, right? At the center, you got a column. Sometimes the beam is supporting the column above, and you got some loading coming from above floors, which is 100 kilonewton here. So that again is a concentrated load, or sometimes called point load, acting right at the center. Delete this line here. And then in the following weeks, usually we try to simplify a diagram. We don't draw the diagram like that. So in structure, we just sort of try to simplify the thing. And so we just redraw the beam here. And those two supports are represented by these little triangles, right? So those are actually representing the support. That's what we said last week, right? Support. So all structure has support. In this case, your structure got only one element. That's the one and only one element in this structure. And there are two supports. Okay, and this concentrated load is represented by this arrow here. That's 100 kilonewton acting downwards. And on the left and right, as we said, there are two supports. These two supports are trying to support or share this 100 kilonewton. So you just divide 100 by 2. On each side, you got 50 kilonewton. So 50 kilonewton will go to the left support. Another 50 kilonewton will go to the right. Or you can say the support on the left is giving a 50 kilonewton pushing up. Try to balance this load. Same on the right hand side. So this R, this capital R, it's the word reaction. That means the force and the support that try to balance this load. So how to find that? Easy. You just divide 100 by 2 because there are only two supports supporting that load. Now on the left side, it's a bit more, it's not complicated, but you got, instead of just one person sitting on the beam, you got 1, 5, 6, 7, 8, 9. You got 9 persons sitting on the beam. And assuming that these 9 persons are exactly the same height, same weight, everything are the same. So let's say each person is again 50 kilogram. In other words, altogether you got 9 persons. So you got 9 persons. But we're not going to treat these as 9-point loads. We just treat all of them as a distributed load, because they are just everywhere. And we try to say, because as I said just a minute ago, each of them are exactly the same, right? They are all 50 kilograms, same height, same weight, everything is the same. So that means the loading along the beam are the same everywhere. So that's why this distributed load is uniform. That means it's the same everywhere. So we say this is we treat these 9 persons as a uniformly distributed, of course it's a live load. In short, we just write UDL. And then we try to calculate the magnitude of the UDL on this beam. So, okay, let me do it here. So this UDL is equal to the total weight of these 9 persons. So that means 9 times 50. And that's kilograms, so I need to change it to kilonewton. So to change it to kilonewton, you multiply by 10 and then divide it by 1,000. That means, so I multiply by 0.01. That gives me kilonewton, right, for the total weight. And then I divide this by the length or the span of this beam, which is again 4 meters. Right, this is the span. So I divide it by 4. So that will give me 1.125, and And the unit is the most important thing, that's kilonewton per meter. Right? On the top is kilonewton. On the bottom is meter. So kilonewton per meter. Or in other words, I treat the weight of these 9 persons as a UDL with 1.125 kilonewton on each meter along the length of the beam. 每一米上邊有1.125個 kilonewton. Okay, that is the physical meaning of this number and the unit. And on second case, just right below it, you have a brick wall, 100 kilonewton total weight sitting on the beam. So that means it's again a uniformly distributed load, assuming that the brick wall is the same thickness everywhere, same height, same thickness. So it's uniform. So for this case, you can also calculate the UDL. So the UDL for this case is 100 kilonewton is total weight. Right? I don't need to change the unit because it's already in kilonewton. So, and then I divide by 4, the span of the beam. That will give you 25 kilonewton per meter. And then at the bottom, it's just same thing, right, like the concentrated load case. I try to simplify the diagram. Right? Instead of drawing that thing, that is my beam, and then I got 2 supports on each side, right, 1 on each side. And then I try to use this symbol to represent UDL. This is just a symbol. Right, so in the remaining weeks, in the coming weeks, whenever I try to describe UDL, I just use this symbol. Right? I don't need to repeat. So you understand that it's the symbol for UDL. So that is for the case of the brickwork. So that would be 25 kilonewton per meter. And just like the concentrated load case, you can calculate the reaction at the support. So those reactions are very simple to get it, right? So 100 kilonewton is the total, and there are 2 supports, so you just divide by 2. So you got 50 each. So each of the supports should be able to carry or share or support 50 kilonewton. Right, so up to now all these calculations are very simple. Okay. Right, so that it's so much I want to talk about loading for the time being. I will switch back to material. Right, of course, I'm not going to repeat what Kelvin Sue has already taught you. So, what I try to do here is to write down some numbers for some important parameters, so that at least everybody in construction should have a basic, very basic idea about some of the common materials, so concrete and steel. you are going to work in construction industry, then these are the things that you see almost every day. So some of the properties are probably you have heard of it before, like strength, density, breakthroughness, ductility, durability is something we said last time. Fire resistance, and of course most importantly is the cost. Of course I'm not going to talk about cost. Density and strength are probably the most important parameters about material. So let's just write down some of the concrete and steel. Some of the numbers actually you should try just to remember. Say for concrete, what's the density of concrete? Right, that should be about 2,400 kilogram per meter cube. And to give you a better idea, don't just remember the number actually doesn't make much sense. The important thing is how heavy is 2,400 kilogram. Right? So let's first change it to kilonewton. So instead of kilogram, you change it to kilonewton. That will give you some unit of loading. Right? So if you change it to kilonewton, that will give you 24 kilonewton per meter cube. So Yat La Phong Mite, right? So what we're talking about is Yat La Phong Mite. So that's Yat La Phong Mite. 1 meter, 1 meter, 1 meter. A cube of concrete. That solid piece of concrete. That's about 24 kilonewton. So what is 24 kilonewton? 24 kilonewton is about 2.4 tons per meter cube. Right? So how heavy is 2.4 tons? 2噸幾大概有幾多呢? That's about the weight of a private vehicle. 架私家車大概1立方米嘅石屎大概就係架私家車咁重。So it's pretty heavy. But when you compare the density with steel, then this is very light actually. So for steel, it's about 8,000, a few times heavier. Right, so 8,000, if you change it to kilonewton, that will give you 80 kilonewton per meter cube. That's about the weight of 8 tons. So it's more than 3 times heavier than concrete. It's quite heavy. So just give you some more idea about how heavy are the stuff. Let's look at one more case. It's not construction material, it's something that make up you and me, bone. What about the density of bone? On average, that is about 1,000 kilogram per meter. That's the density of human bone, on average, of course. Okay. 即係阿婆阿伯佢哋當然冇唔同，骨質疏鬆啊流失咗，尤其老咗嘅女性 ，OK， 即係更年期啊停經之後，咁佢哋嘅骨質流失得好快。So that is about only an average. So it's lighter than concrete. It's of course much lighter than steel. This density, this weight, it's about the weight of soil, another common material in construction. For soil, the density is about 1,800 up to around 2,000 kilogram per meter cube. So the weight of bone is about the weight of soil. It's heavy, right? It's not something very light, but definitely lighter than concrete and steel. Right? So it's better to have some idea of how heavy are those things. And then what about the strength? So in Hong Kong, when we talk about concrete, we usually specify what grade we usually use for building in Hong Kong. So usually C40, 20. C40 and 20, that's how we name grade of concrete in Hong Kong. You should have learned this in the material part. So what does 40 mean? That's the strength of concrete. 20 is the maximum aggregate size. You know what is aggregate? Right， 就係撈石屎入邊最大粒嗰隻石仔，20 mm。20 mm 都唔係細。Right, and 40 is the strength. The unit is Newton per millimeter square, so 40 is the strength, Newton per millimeter square. But nowadays we have a lot of high strength concrete, 好多高強度石屎㗎用到。So for high strength concrete, it's about 100 Newton per millimeter square. It's not very common, but for some very tall building, sometimes we use high strength concrete. 高強度石屎通常起喺度好高嘅樓宇嗰度，咁你就可以 column 就細啲，牆身又薄啲，慳翻好多 floor area 出嚟。Of course, it's much more expensive. 但係唔緊要啦，而家買樓咁貴，呢啲 construction 嘅錢好少。Right, so for high strength concrete, I just put it here as a remark. High strength concrete, it's about 100 Newton per millimeter square. So it's a few times stronger. But when you compare with steel, it's no big deal, right? 100 is still, if you compare with steel, it's more actually. For steel reinforcement, we use in Hong Kong, we're talking about 500 Newton. So when you compare 500 with common concrete grade, that's more than 10 times, 12 times. A lot stronger than concrete. So if you compare concrete and steel, it's funny. Steel, on one hand, is much heavier than concrete. So that's, in some sense, not a good material. Heavier means you got a bigger foundation to support. So it's a bit more expensive. But at the same time, it's much stronger. It's more than 3 times heavier than concrete, but it's more than 10 times stronger than concrete. So as a whole, if you compare these two materials, it's better to describe in terms of this ratio, not just one of them. So if you compare the weight to strength ratio, of course, steel is much better. Right. What about bone? Do you think bone is that strong? Let's say, is it stronger than concrete or weaker than concrete? Any guess? 你啲骨頭勁過石屎或渣過石屎？咁咧當然咧就係因人而異嘅。 即係你攞阿婆嚟比較，咁當然係就冇得比較嘅。So on average, the strength of bone, of course, that number is again an average. It's pretty strong. 冇睇小你自己，強過強盜做石屎。